Hi, I'm Kate. So Hamish told me I could talk about anything I wanted. And so normally I talk about technology leadership stuff, and today I want to talk about software team velocity. How many people wish their teams could go faster and get more done? Anyone? Some people? I th- As someone who manages technology teams, that's like my greatest wish, is like we can get more done in less time. I want to talk to you a little bit about that and a little bit about how to think about your systems and your teams to optimize for speed. So who am I? Hamish gave me a bit of an introduction. I work at Google. I've also been in startups. Before I came to Google about 3 years ago, I was in startups for over 10 years. I've been on teams as small as 4 people. And as big as thousands of people. And so because of that, I feel like I have a very unique perspective on a lot of different companies and a lot of different ways team works. So with that, let's talk about velocity and what is software velocity. So the classic definition is it's speed with direction. And the first part I want to talk about is the direction piece, because most people don't actually think that much about it. In fact, I think one of the biggest failure modes I've seen in startups is you actually build the wrong thing. The very first startup I was part of, we built a video search engine, but it was where you searched inside videos. This was actually like incredibly cool. We used computer vision and audio transcription, and we wrote all of our own search, because this is back in early 2000, before YouTube. And we worked on this for like a year, and we had a prototype, and we took it to our customers. And we're talking to like all the big news agencies in Hollywood, and they're like, hey, can you just help us get our videos on the internet? We don't actually care about searching them. And it was really interesting, because it was my first time I learned that just because you work on something interesting, it doesn't mean that it's actually useful. We solved a very hard engineering problem. And while that was on a bigger scale, of course, you see this a lot with a lot of different teams, where you really work and you do all this work, and then you realize that you've built the wrong thing. And I always use the analogy that it's like you're running towards a light at the end of the tunnel, and you don't really know what the light is, but then when you get there, you're like, oh, wait, I was on the wrong road. And the way you solve this is obviously talking to customers. This is a quote I love from the Intuit founder, Scott Cook. The interesting thing, though, is that how many people who are engineers actually talk to the customers that use their product? Usually it's not very many, especially in big companies, because you have like amazing customer support teams, and you have salespeople, and you have marketing, and you have all these other people that are talking to the customers. And so there's no feedback loop. And this can be really problematic, because if you haven't built that, it can cause a lot of problems. Whenever someone actually building the product doesn't know and doesn't really understand how it's going to be used, it can be very problematic. And I always talk about it how your success or your failure is the summation of all the decisions that everyone on your team that's working on it are making every day. And this is really important to get right. And I like to use the analogy of testing. So imagine that we are building a prototype, and I have someone who, for them, code is a craft. Who's ever worked with someone like that? They're really good at writing lots of tests. Performance test, UI test, unit test. But the problem is, if you're working on a really early stage product, like a V1 of something, there could be a lot of changes as you experiment and you actually learn what people use. And so if you have someone like this on your team, and this did happen to me once, and they build all these tests, what ends up happening is it actually slows everyone else down. Because whenever they go to check in, a test breaks, or they have to go update it, or it takes too long to run. And in this way, this one decision where this engineer felt like they were doing the right thing actually will compound over time. And so in this way, it's really important that you make good decisions at the start. And so how do you do that? On an engineering team, I think it's really important that people understand the success criteria. Like, is this a prototype? Is this a test? What does this mean, right? So how do you measure success? The other kind of tried and true ways that people use is like, having, as much as I hate like mission statements and these value things like you have to go to, they can actually be really useful for you to understand what are the values, like what are the variables that we're optimizing for as a team or an organization or with our products. The other really important thing is I often have talked to engineering teams, and you'll talk to people and say, well, I know what I'm doing this sprint, but I'm not sure a next time. Like, it always changes. And I think that's really problematic, because how will people know if they need to build something really big and scalable, or if they do need to build something that is going to be experimented on, right? Because you can fail just as badly if you don't have all those really great tests and you're deploying to tens of thousands of customers, right? So you have to be smart, and you have to make sure people understand the goals. The other really key part about direction is flexibility. If your team can't adapt, you will fail. I love this quote from Charles Darwin, but no matter how good of an innovator you are and how well you've thought about what you're going to do, if you haven't actually, like, you can't make changes when you have new information, then you're not going to be able to adjust. My favorite model for this is actually one this is from Amazon. So in Jeff Bezos' letter to shareholders in 1997, he talks about the concept of a one-way and two-way door. And the idea here is that if it's a two-way door, it's like a decision that is reversible, right? You can roll back the release, you can make an adjustment, you can kill the feature, whatever it is, right? Whereas a one-way door is maybe something that is very hard to go back on, like a database migration, or hiring a person into a role can be very difficult, right? So in those decisions, you want to have maybe more levity in making them. And I think this model is really helpful, because what you can do is, if it's a two-way or reversible decision, maybe you can have less oversight or push those decisions down into your organization and allow people to make them on their own, because you can always go back, right? So this is, in my mind, one of the keys to being adaptable and making changes. But enough about direction. I want to talk about speed, and this is where the bulk of my talk is going to be, because I think this is the more interesting part, which is kind of this idea of how do you actually move faster as a team. And really, when you think about speed, what is it? It's really distance over time, but for my talk, it's going to be work over time, because that's the analogy I'm using. And so in this case, like, if you think about it, there's really two ways you can optimize this equation. One, you can think about the throughput, or the distance, right? How do you go further? How do you be more productive? How do you get more done? How do you be more efficient? These are things like different clouds or libraries and things can give you in your software stack. They can allow you to get, remove abstraction and let you move faster. The second way is latency, which is the name of the conference, and like kind of why I picked this topic, which is that it's how long can it take to move work through the system. So I often think about this as like, how much bureaucracy do you have that's slowing your team down? How much structure? So how do you make this better? And so first, I want to talk a little bit, this is going to be like the technical part of my talk. How do you design your systems to optimize for better throughput? So specifically, I'm just going to talk through some stuff. I'm actually going to go through it really quickly, because most of it is fairly common sense and things that you might know if you've worked on distributed systems. But I do want to kind of talk about each of them in turn and how they help with velocities. So the first part is APIs. So APIs in your API design is really important in Teams velocity. How many people have ever seen what I call the Swiss Army knife API that does everything? Has anyone ever seen one of those? It's like the most broken design pattern. Like, if you use this bit mask, you can, by outputting this, it'll do this and this. I'm like, whoa, this is complicated. But I have seen a lot of these in my career. Over time, what has been shown that simpler, like very straightforward, intuitive, like not that many parameters, these sort of APIs are the ones that are easy to maintain. They're easier to keep, like backwards compatible. And they remove the complexity. You really want to go for simple here, because that's going to allow the teams that use your APIs not to have friction, and for the APIs that you use and consume, hopefully to be easier and not have to spend a lot of time dealing with migrations and deprecations. The second thing is making sure that you're smart about how you're using your database. I've seen many applications where you have different services writing directly to the database, sometimes even the same tables. And this may seem like a very fast and efficient way, but it's a very broken thing in the future, because what happens is you don't know who's reading what or what they're doing with what. And once you start to get in a very distributed situation, it's a great way to have those bugs that you can never really understand what happened. So best practice, you can Google this, is the single writer principle. It just has this idea of encapsulation. It's very helpful in how to think about access to your data. Another important part is decouple components. How many people have seen someone who got really overzealous with their object-oriented programming and everything is like an object? Well, everyone could reuse this. This is so helpful. Yeah, so it's really important, the concepts of fan in and fan out. So when you want that and you want reuse, you might fan out and create more components versus fan in and create an abstraction that hides that complexity from the other services. So being really thoughtful about what components and what interfaces you have and how much abstraction and complexity you really expose, right? So it's really thoughtful about your system and code design. The other important thing is I once took over a team. I had 8 different teams working for me, and every single one had a different tech stack, whether it was a different database or different language or different front-end framework. And I felt like at any given time, one of the teams was dealing with some sort of deprecation or patching or migration. And there were no economies of scale. There wasn't a way of like one team or one person being able to manage it across all these teams, and so it created a lot of churn. And so now I've become almost a dictator around this of like, I don't care what the best tool for the job is, we're not introducing another whatever new framework of doing things. I think this standardization actually can really help when it comes to speed. While it might slow down individually, over time, having really solid standards across your products or your organization can help you both leverage other people when you need to like get more done, or even just around making sure that you have the expertise and can manage when things change or need updates. So the last two are kind of, they go together. Sorry, I'm gonna grab a drink of water. Which is to think small. When you have, this is obvious to most people, when you have small iterative releases, it's easier to roll back, also easier to manage the risk. So overall, it helps you move faster. And a key part of that is testing. But I always talk about it of the Goldilocks type of testing. You want not too much, where it actually slows things down. I once worked in a code base where literally the tests took longer to run than the time it took to write the code. Has anyone ever been in a situation where the builds took longer than, yes, that's very, very painful and very hard to work and definitely not in line with speed. So you want enough testing that you can feel really confident, right? And a really good way to think about testing and the concept of team speed is to think about the interfaces you have with one another and making sure you don't ever introduce regressions and break other people. So the key takeaway for thinking about throughput in your systems is really there's a lot of great distributed system design best practices, and if you obey them and you have different people working on different systems, it should actually really help you. So now I want to talk about the latency part, and so this is the stuff I think about all the time, which is how do you think about your team and how you structure your teams and people actually working on stuff to get more done. So how many people have heard of the Universal Scalability Law? Maybe some people. It was introduced by Neil Gunther a long time ago in a paper about performance dynamics. And he talks about it as this idea that in an ideal system, the amount of throughput will be directly correlated to the load, right? So if you think about it in terms of a team, if you have the number of people should scale linearly with the amount of work they get done. So if I'm one person doing work and I get done 1 unit of work and you add a second person, we get done 2 units, so on and so forth. Now in the real world, it doesn't work like that, if only. Because in the real world, we actually have interesting things that happen. So in a system, contention is like when 2 threads are trying to access the same resource and one has to wait for the other. You have to block on a write to a database or something. Well, the same thing can happen in a team. So imagine that you have Bob and Sally here and their boss is Spider-Man, because I thought Spider-Man was a good person to have as a boss. And, and they don't agree on something. And so in order to move forward, they're in a contentious situation. They have to have Spider-Man tell them what to do. And so in this way, Spider-Man becomes a contentious resource that slows down the ability to get work done, right? And you can imagine how this can get worse as the teams get bigger or as there are different things. But there's lots of other things that can cause contention, right? Two people working in the same file. And so, and you know, they have to, you know, if both people are checking in, they can step on each other's toes, right? So what people do is they create structure, right? That's why we have branches, and then we merge them, right? These are things that are structure that people have introduced to help us actually be more efficient when we work together. The problem is sometimes, you know, structure has a sweet spot, right? You don't want too much structure if you don't need it. Otherwise, you can introduce so much structure that it's not very productive, right? So there's this part where you have to think about it. And it's all about managing this contention of resources in like a system. And so with our contention, now our graph looks something like this, right? So you now have, the work is pretty linear with the right people and the right process, but then at some point, it starts to flatten out. And adding more people is actually not going to help us get the project done faster, right? You had more people working in this code base, and it's just not going to work, right? So people, I'm sure most of you have encountered something like this. So the next thing I want to talk about is a little bit about coherence. And so in a small team, like say a startup, there's, you know, if you have 5 people, you have 25 different communication pathways. Fine. If you're in a big team, it gets worse. And it gets worse fast, right? Because the communication pathways are the square of the number of people, right? So it's n squared. And the problem is that getting agreement when you have all these people can be really hard, right? And especially if you get even bigger, and each of these people are representing a department, right? Because then they have to get coherence within that department before they can go to the next one. And so this is kind of another way of looking at this here, is that actually now the more people that you add, because of coherence, it actually decreases your productivity because you're spending more time in meetings and more time getting everyone aligned with the technical direction or solution you want to implement. And so in this way, you know, it's really important to think about how you're organized, right? You want, for coherence, you want the minimum number of people required to make decisions, right? And this is where the one and two-way door kind of model can help you. But you also want to think about how you design your systems to minimize the amount of coordination and contention of resources and teams. All right, let's talk about another model for thinking about team structure. Sorry, I really love these models applied to different leadership concepts, as you will. So when you think about your team structure, a lot of teams are organized like this. I actually hate this. So it's, you have these verticals of like, here's the product team, here's the engineering team, here's the operations team. And then you have what are called like these matrices of like, okay, now this group of people is gonna go work on this outcome, right? That's sort of what this diagram is depicting with all my people. And it seems like a really good idea in theory because you get these efficiencies, right? Like people get mentoring from the other people working on product, and we want everything to look the same. So having all of UX report together makes tons of sense, right? These are really good. In a startup, this is not how it works. In a startup, everyone's on the same team. In a really small startup, everyone's working on the same exact stuff all the time. You're in the same sprint, right? And so that's, you know, this slows things down. And let me explain why this is like really bad for speed. So imagine that you have Bob, our friend here. If Bob is working on a project, the project's success is directly correlated to the probability of Bob's work, right? So if Bob puts 99% effort, because nothing is ever guaranteed, so you can't put 100%, then there's a 99% chance of success. This is great. But now let's bring Sue back into the equation. Now you need both of them to work together to do it. So they work here, 99%, you're at 98%. That's okay. Like, you're still doing really well. But now, let's send our friend, I don't know what we'll call him, George. George is a good name for a knight. And you have these 3 people, and they're working on a project, and they all put in 99%, right? You're at 97%, but you're good. you're still very successful. Let's say that George happens to work in this UX team that I talked about. And they have a bunch of summits, and they have to do these style guides. And all of a sudden, his ability to contribute to this project goes down to like 80% of his time because he's really busy with all this other horizontal stuff. And now if you look at this, this actually is very detrimental to our project because we're now at 78%. And this gets even worse as you get with more people, right? Because the number of people, it's, the exponential probability. So if you have 15 people giving 99%, you're at 86%. And that's 15 people all giving their best effort, right? And now let's say it's 95% because they just have a little bit of overhead in their team. Well, now the success of your project has gone way down. Of course, in real life, that's not how it works because some people actually give more than 100% and compensate and things like that. But I think it's a really helpful model in how you think about matrixed organizations and how you think about people's productivity and what you're optimizing for. And again, like speed may not be what you care about, like speed may not matter in your organization, but like I said, most teams do want to move faster. And so in this way, this is my kind of takeaway for you, is to think about the probability of the success of your project has an exponential relationship to the number of people involved. And so this is really important to think about. And so when you design your teams, even if it's matrixed, the most important thing is that they have the same goals. So you can't afford to have George off doing all this other work. You need George as focused as you can on your project so that his 80% goes up to 90, right? So even if you have the matrix organization, you need to really think about how things are staffed and make sure that you're not taking percentages of all these people. And so I think that was a lesson that was learned the hard way in my experience. So another important part in distributed systems, if you deal with lots of data, one of the first lessons you learn real fast is that the closer the data is to whatever operation you're doing, the faster your service will be. And so look, this actually works also with people and org charts. And so applying this principle here, I want to talk a little bit about the Netflix culture doc. How many people have read this, the old slideshow that they did? Okay, if you haven't, and I don't work for Netflix, but go to netflix.com jobs. They actually have an amazing manifesto about their company culture and how they think about their teams. And one of the things they talk about is how their teams are highly aligned, which is the part that we just talked about aligning your people, and loosely coupled, right? So this notion of these shared interfaces. And I think they just do a really good job of talking about it. But I wanted to talk about friction in org charts and how this causes problems. And we'll come back to this, why this coupling is so important in these interfaces. So let's go back to our friend Bob, and he's working with Susan, and they have a technical disagreement. And disagreements can happen for lots of things, right? Like it could be, they don't agree with the approach. It could be they don't really like each other. It could even just be they don't have a lot of trust, right? There's all sorts of reasons friction can happen. But in this case, they work for Spider-Man, and Spider-Man's awesome. And so he's able to mediate their disagreement, and they're all back to being happy. But let's say in this new org chart that's not the case, that Bob and Susan have different managers. So, and let's say that, I don't know what this person's name is, but Spider-Man and the princess over here can't get along. They don't agree. So they have to escalate. And so this takes time. But Batman can... My son is convinced that Batman can solve anything. It's like the hero in our household. So Batman can fix this. So Batman's able to fix it. But the interesting thing here is that if you think about it, the further apart teams are from one another, right, and that are working together, the more difficult they're going to have working, in those relationships, and the more overhead and coordination and cost this is going to be, which can really, really slow you down, right? It's kind of that coherence that we talked about earlier, but like magnified. And so it's really important to think about your teams and even your organizations for how you work. And so Netflix talks about how they solve that is like having these really clearly defined interfaces. But the interesting thing, and I only learned about this probably like 4 or 5 years ago, how many people have heard of Conway's Law before? Okay, if you haven't, you'll see it play out in any organization because it's basically this idea that each team will kind of want to control their own destiny. And so they'll build software to like compensate, like, oh, we can't get them to build this API. So we'll just do this other thing on our side that basically should live in the service, but because they can't get it done when we need it to. And so it's interesting because what you see is the software and the architecture ends up mimicking the organization and the logic more than actually like what the systems and the architecture should look like. And so the takeaway here is to really think about like what interfaces that you have and how you can have these like really tightly aligned teams, but they're loosely coupled, right? And ideally not spread throughout the organization in a way that's very hard for you to reach consensus when things don't, when people have friction or disagree. And also, as you think about Conway's Law, to make sure that what you've actually designed supports your business goals and the architecture of your systems. And so with this, I want you to just, hopefully I gave you some interesting ideas or different ways of thinking about things and ways that you can move faster as an org, whether it's thinking about how you're designing your systems or your architecture or how you're functioning as a team, or even as a leader in your organization, how you're setting good direction and making sure that your team actually knows like the goals and what you're trying to accomplish. And with that, I can take questions, a few questions. If you can.